Let us consider 8 GB pen drive. It is a memory. How much data you can store there is a 8 GB. Let us stick to 8 GB. Now, how do you measure that 8 GB? Some, you put one file, some space is occupied. You put another file, some space is occupied. You put one movie, some space is occupied. So, till that 8 GB is occupied, you keep on putting the data, isn't it? And once the disk is full, then what you have to do? Of course, you delete something from your mobile also, isn't it? So when it comes to the memory, whether it is a your mobile memory or your secondary disk memory, here 1 terabyte, or pen drive or DVD also for the sake. DVD also has the capacity of 4 GB, only 4 GB. Or the SD card you put in the mobile, external SD card, the storage, to expand the storage, it has a limit. You talk about any memory, here we are talking about a RAM, random access memory, which is there on your motherboard. Now when it comes to any memory, it is a very fundamental thing, guys. Any memory, doesn't matter if it is a RAM, if it is a secondary hard disk, if it is a DVD, or if it is your mobile memory, any memory where you store the data, the first characteristic of the memory is its size. And how that size is calculated, is with the help of an address. This is called as address space. The another term for the memory is, what is another term? Address space. Memory is nothing but the address space. On one address, you see, every student has a roll number here, isn't it? So address. So if I give the chair number, seat number here, seat number 1, 2, 3, 4, 5, 6, 7, 8, you see 1 to 10, 11 to 20, these are the seat numbers. And on one seat, only one student can sit, agreed? Okay. On one address, two students cannot sit. So basically this seat number is like an address in this room. Particularly, let us talk only about this room. This seat number is like an address. Similarly, in the memory, if you have, let us take a small problem. If I have 16 bytes, very small memory, 16 bytes. If I have 16 bytes, these are the 16 bytes. Now let us give the numbering 0, 1, 2, 3 up to, no, we have started from 0 up to 14 and 15. So if I have 16 bytes of memory, then every byte, every student has a seat number here. Likewise, in the memory, every byte has an address, starting with 0 to n minus 1, starting with 0 to n minus 1, where n stands for total number of bytes. 16 minus 1 is 50. So the last chair number is 50. It always starts with 0. Now at one location, only one student can sit. Here in memory, in one location, only 8 bits or 1 byte can be stored. 1 byte, 1 byte, 1 byte, 1 byte, etc. Now this unit, 8 bytes, I'm sorry, 1 byte, uh, you must have digital logic in your, upcoming years or semesters. You will learn about the binary system there, how the binary system works. Like in decimal, what numbers we have? 0 to, what basic numbers we have? 0 to 9, no? Digits. 0 to 9 only. And how do you do 10? It is a combination of 1 and 0. 11 is a combination of 1 and 1. So the unique symbols, how many unique symbols we have in decimal system? 0 to 9, that is 10 symbols we have in decimal systems. Likewise, in binary system we have only two symbols, 0 and 1. In the binary system we have only two symbols, 0 and 1. In decimal, if it is 1, 0, 0, 0, 0, 0, 0, 0, 1. In decimal, if it is 2, in binary it would be, it is 1, 0. So if it is a pattern of 1 and 0. Okay, it is a pattern of 1 and 0.